Welcome to the soothing cosmos, where the wonders of the universe unfold in calm and captivating detail. Here, we journey beyond our world, exploring the mysteries of space, the beauty of distant planets, and the secrets written in the stars. If you enjoy traveling through the cosmos with us, remember to subscribe and join our voyage across the universe. Trans-Neptunian objects, the distant frontier of the solar system. Beyond the orbit of Neptune lies a vast and largely unexplored region of the solar system, home to a diverse collection of icy bodies known as Trans-Neptunian objects, TNOs. These distant worlds, remnants from the early solar system, provide a unique window into the processes that shaped planets, moons, and smaller bodies alike. The population of TNOs includes the well-known dwarf planets Pluto, Haumea, Makemake, and Eris, as well as countless smaller icy fragments orbiting the Sun at distances ranging from about 30 to over 100 astronomical units, AU. Studying these objects challenges our understanding of planetary formation and migration, as their compositions, orbits, and interactions reflect the solar system's dynamic history. In many ways, TNOs represent a frozen time capsule, preserving materials and conditions from the era when the Sun and planets first coalesced. Their study is crucial for astronomers seeking to trace the origins and evolution of our planetary system. TNOs are generally small, icy bodies composed primarily of water ice, methane, ammonia, and other volatile compounds, mixed with rock and dust. Their sizes range from just a few kilometers to over 2,300 kilometers, as in the case of Pluto. Because of their distance from the Sun, these objects remain extremely cold, often below -220 degrees Celsius. The surfaces of TNOs display a variety of colors, from neutral gray to deep red, caused by complex chemical reactions triggered by cosmic radiation over billions of years. Many TNOs have irregular, elongated shapes, and their low gravity means that they lack significant atmospheres, though some, like Pluto, maintain thin, transient atmospheres composed mostly of nitrogen with traces of methane and carbon monoxide. Trans-Neptunian objects are divided into several categories based on their orbits. Classical Kuiper belt objects, QB1os. These objects follow nearly circular, stable orbits beyond Neptune and are not strongly influenced by its gravity. Resonant objects, some TNOs are locked in orbital resonances with Neptune, such as Pluto, which maintains a 3:2 resonance. Scattered disk objects, these have highly elliptical and inclined orbits caused by past gravitational interactions with Neptune. Detached objects, their orbits are so distant and eccentric that they are largely unaffected by Neptune, raising questions about the influence of yet undetected massive bodies. The collective motion of these objects reveals a solar system far more dynamic than previously imagined, with the potential past migrations of giant planets shaping the current arrangement of TNOs. Pluto, once classified as the 9th planet, remains the most famous TNO. It has a diameter of 2,377 kilometers and a complex surface featuring mountains of water ice, vast nitrogen plains, and methane glaciers. Its atmosphere expands and contracts with its orbit, and it has 5 known moons, including the large Charon. Other dwarf planets in the Trans-Neptunian region, such as Eris, Haumea, and Makemake, also display remarkable characteristics. Haumea, for example, is elongated and spins rapidly, while Eris, slightly smaller than Pluto, has a highly reflective surface covered with frozen methane. Each of these worlds provides critical clues to the diversity and evolution of objects in the distant solar system. Far beyond the Kuiper belt lies the hypothetical Oort cloud, a vast spherical shell of icy bodies surrounding the solar system at distances up to 100,000 Australian dollars. While direct observations remain elusive, the Oort cloud is inferred from the trajectories of long-period comets, which originate from this region. These icy bodies are believed to be remnants of the solar system's formation, scattered outward by the gravitational influence of the giant planets. Occasionally, perturbations from passing stars or galactic tides send these objects into the inner solar system, creating spectacular comets that can be observed from Earth. The Oort cloud represents the ultimate frontier of our solar system, connecting the Sun to the interstellar medium. Exploration of trans-Neptunian objects is still in its infancy. The most notable mission is NASA's New Horizons, which performed a historic flyby of Pluto in 2015, followed by a close encounter with the small Kuiper Belt object Eris, formerly 2014 MU-69, in 2019. These missions revealed detailed surface geology, composition, and atmospheres of these distant worlds, challenging assumptions about their simplicity. Future missions aim to explore additional TNOs, providing in-situ measurements and potentially even sample returns. Advances in telescope technology, including the James Webb Space Telescope, continue to expand our ability to detect and characterize TNOs from Earth. Studying TNOs illuminates the early history of the solar system. These bodies preserve primordial materials and chemical signatures from the solar nebula, providing insights into planetary formation, migration, and the delivery of volatiles to the inner planets. Additionally, TNOs help astronomers understand the limits of planetary systems, revealing the interplay between gravity, orbital resonances, and long-term stability. By examining these distant worlds, scientists gain a broader perspective on planetary systems beyond our own, informing studies of exoplanets and the potential for habitable environments in other star systems. The next decades promise further discoveries in the Trans-Neptunian region. Proposed missions include orbiters, flybys, and landers designed to study TNOs in unprecedented detail. Ground-based and space telescopes will continue to identify new objects, expanding the known population and refining orbital models. Continued observation and exploration of TNOs may also reveal new classes of objects, unknown moons, or even undiscovered planets in the distant solar system, offering surprises that challenge current theories of solar system formation. Trans-Neptunian objects and the Oort cloud form the final frontier of the solar system. Their icy surfaces, diverse orbits, and preserved primordial materials make them invaluable to the study of planetary science. From Pluto's dynamic surface to the distant reaches of the Oort cloud, these distant worlds remind us that the solar system extends far beyond the familiar planets, holding secrets that continue to intrigue and inspire humanity.